Hey, for all of those of you traveling out there or gone from chemistry class for some other reason today, just wanted to give you a quick overview of what these notes were about. So what we were looking at today was specifically finding the pH of strong acids and strong bases. And so this is just a list of strong acids and strong bases: hydrochloric, hydrobromic, hydriodic, perchloric, sulfuric, phosphoric, and it looks like I've left off here nitric, HNO3. Now, for these strong acids, the hydrogen ion concentration, as we call this, or you remember another word for that is the hydronium ion concentration, equals the acid concentration. Now, this is for strong acids as long as they're fairly concentrated. So here, what we see happens with sulfuric acid is when it dissociates, it really dissociates completely with this one hydrogen, and then this ion remains behind. And so this second hydrogen has very little effect on the hydrogen ion concentration as long as the concentration of the sulfuric acid itself is greater than, say, about 0.01 molar. And we're getting kind of close to a line there where it may, if it's less than 0.01 molar, it'll have a noticeable effect on the pH. So to calculate the pH of a strong acid, then we just use our formula for calculating pH, that the pH is the negative log of the hydrogen ion concentration. So in this case, we calculated the pH as 2. Now, if we look at calculating the pH of strong bases, it's similar in that here we have sodium hydroxide, which of course has the hydroxide ion in it, and when it dissociates, the concentration of the the concentration of the sodium hydroxide here initially is exactly the same as the concentration of the hydroxide ion. And so usually what we do is find the pOH, since we have the hydroxide ion concentration. In this case, that calculated out as 2.3 for the pOH, and then from that we calculate the pH. pH equals 14 minus the pOH, or in this case 11.7 is the pH. Now, a lot of students then are sure to notice that we certainly have a pH greater than 7, and we would expect that from a base. Here's the thing you've got to remember, though, about strong bases. Some of them, like barium hydroxide, when they dissociate, for every mole of base we have, we actually get 2 moles of hydroxide if we balance this equation. So in this particular example, we can see that even though we started with the same concentration as we did in the first example up here, that because we have 2 moles of hydroxide produced for every mole of barium hydroxide that was present, the pH actually is as low as 12. And then if you look at the next couple of slides on the blog, you'll see that they're about a short quiz that we had. And so you may want to look at those. And that about wraps it up. Hope you're having fun wherever you are.